which concludes the President's emergency announcement about oral hygiene. This is Ford Harrison. Thanks for watching.
This has been a breaking news report. We now join Robot Astronomy Talk Show, already in progress.
We're going to crash! On top of Old Smoky isn't helping any more than Clementine was. Cameron Diaz, I'm beginning to think tuba music isn't the answer here.
Really? Thought that would do the trick. Well, it certainly was a wild series of events that sent you on this collision course, but with the giant doomsday carrot and all.
Why are you recapping what we all just saw less than 2 minutes ago? We need solutions, woman!
Well, have you tried to measure the mass of this asteroid?
What? Why would we do that? Is this busy work?
Yes, but knowing its mass could help you for reasons you explained in the first half of the show.
But we robots don't have the equipment to measure its mass directly.
Well, technically, neither do we humans. But some scientists at NASA's Jet Propulsion Laboratory have developed a clever trick to measure asteroids' mass from a distance.
Great. More pro-human propaganda.
It's a technique pioneered by JPL's Near-Earth Object Program Office in 2012. You see, we can use mathematical models to determine where many asteroids are orbiting. We've also used ground-based telescopes to track where those asteroids actually are. And where they are, and where they should be, don't always match up.
Because of human incompetence.
No, because of something called the Yarkovsky effect.
The Who's-he-what's-he?
Oh, the Yarkovsky effect is very cool. When light shines on one side of any given object, that object heats up and gives off infrared radiation. Because photons have momentum, that infrared energy gives the object a little push, like tiny little spaceship thrusters. The effect is most noticeable in a vacuum.
Are you joshing me?
I am not joshing you.
So you're saying that when an asteroid absorbs sunlight on one side, that side emits infrared energy that pushes it out of its normal orbit?
Exactly. The more sunlight it's able to absorb, the more infrared energy it emits, and the further it gets pushed. As it turns out, we can measure that infrared energy even from as far away as the Earth. It's just too bad that you don't have an infrared observatory like the Spitzer Space Telescope nearby.
We do have it! It's falling right beside us! You do remember the exciting first half of our show.
Oh, of course, right. I must have been distracted by the doomsday carrot. Well, this is great. You see, Spitzer can measure how much infrared energy is coming from this asteroid.
Producer Bot, tap into the Spitzer Space Telescope and measure the infrared. Got it.
Great. Thanks to the Yarkovsky effect, we know how much force is pushing against this asteroid. And remember, we've already seen that these asteroids aren't where they should be in the sky. That means that over time, we can measure how much they're accelerating away from where they should be.
Okay, so we know the force and we know the acceleration. How does this give us the asteroid's mass?
That's thanks to a little formula called F equals ma.
Cameron Diaz, we have a strict no-math policy on this show.
Don't worry, it's actually quite simple. Okay, so we know how much force is pushing against the asteroid thanks to Spitzer and Yarkovsky.
Right.
And this formula tells us that force equals mass times acceleration.
Okay.
So, since we know the force, measuring a large amount of acceleration means the mass must be small. Measuring smaller acceleration means the mass must be larger.
Ah, like pushing a tricycle or a car. The tricycle will accelerate a lot faster than the car because it has less mass.
Yes, it's the same with asteroids. And if we plug in our actual measurements for the force and acceleration,
we can calculate exactly how much mass the asteroid has.
Exactly, which means we can measure the mass of even very distant asteroids quite accurately, all the way from Earth. And that is the groundbreaking technique those JPL scientists revealed in 2012. Here's a link to the web story, if you'd like to read more about it.
No time. Producer Bot, use the mass of this asteroid to calculate a safe trajectory away from here. Woohoo! It's working! Now we can resume conquering the universe! So long, you big dumb asteroid. And so long, Yarkovsky effect.
Oh, the Yarkovsky effect doesn't just apply to this asteroid. It's pushing asteroids around all throughout the asteroid belt.
Wow, thanks for the trivia. Wait, that's not trivia, is it? Rats.
You know, the Yarkovsky effect is probably even pushing around that doomsday carrot.
Yo!